Okay, hello again. So this will be 4D. Remember, if I ask a question, try to answer it. If you need to pause the video so you have a little bit more time to answer it and think through it, you can. Also, remember, if you get stuck, you're confused, something doesn't make sense, make sure you send me an email so I can explain what is happening. So this section, 4D, is just two problems. And in this part, we're going to have FNs that are not equal to mg. Okay, so we're going to make this a little bit more tricky. It's not going to be quite as simple. So first I'll read this problem. A student moves a box of books by attaching a rope to the box and pulling with a force of 90 newtons at an angle of 30 degrees. The box of books has a mass of 20 kg, and the coefficient of kinetic friction between the bottom of the box and the sidewalk is 0.5. Find the acceleration of the box. This one also, A is not equal to 0, so that's going to be a little bit different from what we did before. Okay? So, what's our first step? Yeah, that's right. Our first step for these force problems is to draw a free body diagram. So go ahead, pause the video, and draw this, and see if you can get the same thing that I do. So I'll wait for a second. Okay, welcome back. Hopefully you have a beautiful free body diagram drawn. And let's go ahead and see if I can get the same one you have. So first of all, we have mg, we have Fn, okay? We're going to have an Ff going back against my motion. And then I also have this force, but it's not a straight applied force. It's actually at an angle, okay? So this angle is 30 degrees, and then I'll label this Fa. Okay, now, this is the part where it gets a little tricky. Now, we kind of already learned this, but you'll notice this force has a component in the x direction and a component in the y direction. So I'm going to need to split it up. Now, in the x direction, remember, we should know this and should be pretty confident about this by now. What would it be? There's three parts, right? Blank, blank, blank. Okay, hopefully, you said Fa cosine 30. Okay? And in the y direction, we're going to have what? Yeah, Fa sine 30. Okay? So now I have these two components. So now when I set up my xy chart, Fa is going to have a part in the x and a part in the y. So this is going to make this problem a little bit trickier. So let's go ahead and set up our Fx and Fy. Okay, now in the y direction, is this box going to start floating away or sinking into the sidewalk? No, we wouldn't expect that to happen. So our Fa, because it's not moving up or down, we know the acceleration in the y direction is what? Yeah, the Ay is going to be equal to 0. So if I know Ay is equal to 0, then what do I know Fy is equal to? That one should also be 0. It's sort of like the F net in the y direction is equal to 0. Okay, so this is my F net in the y direction, this is my F net in the x direction. Since this is 0, my Fx is my F net. Okay? So I have my Fy equals 0. Let's go ahead and start putting some forces in here. So in the x direction, I have Fa cosine 30. I need to start worrying about positive and negatives here. Will Ff be positive or negative? Yeah, we probably should make it negative since it's backwards. Got a bell. So negative Ff. And do we have any other forces in the x direction? Yeah, those are our only forces in the x direction. So let's go ahead and look in the y direction. We have Fn. Let's say that's positive. So it means we have what mg? Yeah, negative mg. And then will Fa sine theta be positive or negative? That one should be positive too since we have it up. So I'll have Fa sine theta. Okay? Remember, all of this is going to add up to 0. So I'll put 0 equals Fn plus Fa sine theta minus mg. And then over here, this is actually my F net. So F net equals Fa cosine 30 minus F Now, once I have this, once I have my F net, this will be the formula that I'm working from. Okay? So let's start with this. So F net is equal to FA cosine 30 minus, let's go ahead and plug in our formula for FF. So what's our formula for FF? Yeah, that is mu Fn. Okay, what's our formula for F net? That's MA. So MA, I know FA cosine 30, I know mu, okay, but I don't know Fn. Remember before, Fn was just mg, but now it's not just equal to mg. So I need to come back to this formula and actually solve for Fn. Okay, so oftentimes in these friction problems, you're finding your acceleration or something in the x direction, but you're going to need to use the y direction to find Fn. Okay? So let's go ahead and find Fn here. So let's move both of these to the other side. So I'll have Fn equals, so I'll subtract that one, add that one, mg minus Fa sine theta. Okay? So now that I have this whole big thing, I'm going to have to plug that in over here. So I'll write mu and then mg minus Fa sine theta. Okay? So now to solve for a, I just need to divide by n. So I'll have a equals Fa cosine 30 minus mu mg minus Fa sine 30 all over m. Okay? So you end up with a really long answer. You could plug in and get a number, but I'm not too worried about the algebra part right now. I'm mostly just worried about being able to solve for acceleration. Okay? Remember, if you get stuck, you need some help, make sure you send me an email so I can help you. So we got one more problem. So let's go ahead and look at the second problem. Okay, so we have two students sliding a 225 kg sofa at a constant speed across a wood floor. One student pushes with a force 225 newtons at an angle of 13 above the horizontal, while the other student pushes with a force of 215 newtons at an angle of 23 below the horizontal. What is the coefficient of friction between the sofa and the floor? So we're looking for mu. Okay, mu k. Now, an important thing here is constant speed. So if I have a constant speed, what's my acceleration? Right, my acceleration should equal 0. So if acceleration equals 0, what should my F net equal? My F net should also equal 0. Okay? So this means all the forces are going to have to cancel out. That means both my Fx equals 0 and my Fy equals 0. So those both have to be 0. So this is the part of the show where you pause the video, you try to draw your free body diagram. Okay? So I'll let you take a second to do that. Okay, welcome back. Hopefully you have a beautiful free body diagram. I'll go ahead and draw this. So I have my sofa, my box sofa. I have mg. I have Fn. I have my Ff. And then I have two forces. So let me put like a dotted line here. I have one force that is, I'm just going to put 225, and then this is 13 degrees. And then I also have a force that is 250, and then this is 23 degrees. Okay? So I'm actually going to have to break each one of these forces into components. So I have two different triangles. Okay? I think I have a fairly good confidence that you can break those down. So let's go ahead and skip to our XY chart. So I have Fx, Fy. So let's go through we should end up having 3 forces in the x direction. So I have negative FF, that was the easy one. Okay, this one right here, what will be my orange value for this 250? Yeah, it should be 250 cosine 23. Even though this is a down angle, we know that this direction is positive, right? We're doing something like this. So if this direction is positive, this is still pushing forward. So I have this one. Okay, now let's look at the 225. What will be the component for that one? Yeah, it should be 225 cosine 13. Okay? Now remember, what will all of this add up to equal? What number? Right? This should all add up to equal 0. Okay, so now let's look at our y direction. So in our y direction, we're going to have 4 different forces, quite a few forces. Mg is going to be negative. Is Fn going to be positive or negative? Should be positive. So I have Fn positive. Is this one going to be positive or negative? This 225. Yeah, that one should be positive. So 225 sine 13. And then this one here is 250. Is it going to be positive or negative? Should be negative since it's pushing down. So 250 sine 23, and I need to put a negative there. Okay? Once again, remember, what does this all add up to equal? What number? Right? Should be 0. So Fy also equals 0. Okay? So I know these two must add up equal to this, and then those top and bottom ones must add up equal these middle ones. So let's go ahead and set this up. So I have something like my x direction first. I'll do 250 cosine 23 plus 225 cosine 13 equals FF. What's my formula for FF? That is mu Fn. I'm trying to find my coefficient of static friction. So I'm trying to find this guy here. Equals 250 cosine 23 plus 225 cosine 13. So I need to solve for Fn. And how do we solve for Fn? Yeah, we gotta look at this craziness in the y direction where we got 4 different forces. Okay? So I need to write that one down and solve for Fn. So I have something like Fn plus 225 sine 13 equals mg plus 250 sine 23. Okay? Now remember, we know that the 2 positive ones must cancel out the 2 negative ones, so they must be equal to each other. Okay, so let's go ahead and solve for Fn. So that's actually fairly easy. So just Fn equals mg plus 250 sine 23 minus 225 sine 13. Okay, so all of this here, that's my Fn. So I need to plug that in over here. Okay, so to solve for mu, I just need to divide by Fn. So I'll take and divide by this number here. So I'll have mu equals 250 cosine 23 plus 225 cosine 13 all over mg plus 225. That should be 250. Whoops. 250 sine 23 minus 225 sine 13. Okay, and you could plug in numbers and get an actual number. Okay, but this would solve for our mu. K, since we're moving. Okay, remember, if there was something you didn't really understand or you got confused, make sure you send me an email and ask a question. I usually can respond to emails pretty quickly, so please let me know. Thanks for staying with me to 4D, and I will see you next time.